Okay, good afternoon, everybody. Sorry for being late. This is Dr. Mansour with the Professional Engineering Services and Education, and this is a FE Civil Prep course, and today is March the 3rd, 2024, and this is session 4B. So 4A was the morning session, and 4B is going to start right now. So I hope that you enjoyed your lunch, and I hope that you did some work for this hour and 15 minutes from 1 to 2:15. You get a chance to work some of the mechanics of materials or some statics, or you use your time, whatever time you use. Okay, and I'm sure that you are going to come up with questions. And we're meeting this coming Friday, by the way, as usual, from 5 to 7, the same ID, and we'll keep working. So please go over these problems. And I did my best, but if you find any typo or mistake or something not clear to you, please, okay, let me know, okay? Very, very good set of problems, and I have another set of problems. I will be glad to send it to you. The chapter that, as I announced on Friday, the engineering economics. Economics is one of the chapters that I would say that maybe it depends when did you take it. It is easy chapter, guaranteed type of problems, but also without good preparation and without good understanding of the subject, it might be a tough subject. If you put it that way, even it is easy. And I taught this subject about maybe 50 times or 60 times when I was teaching back in Las Cruces, New Mexico, and also here. Okay, so the subject is not difficult at all. However, it is tricky in the wording, and the wording are really sometimes is too risky. According to the NCEES, we're supposed to or is supposed to have 5 to 8 questions. Engineering economics, time value of money, like equivalence, present worth, equivalent annual worth, future and rate of return, cost, fixed, variable, direct and indirect, incremental and average and sunk, okay, analysis, break-even analysis, benefit cost ratio, life cycle cost analysis, and uncertainty, and so on. So they provide in the NCEES on page 230 of the NCEES. Make sure that this is the right page, 230. Let's go to page 230 and see what they have for us. Exactly 230. Here it is. So this is the NCEES V10.3, page 230. This is what you see. If you have the book, that's one is not here. Okay. So basically, engineering economics, there are 4 quantities we need to be aware of, this is page number 8, and this is 4B. So this is session 4B, and today is March the 3rd, 2024. So engineering economics, here we're talking about the value of money. So basically we have money, and we need to know the value of the money at different times. So they came up with some letters like P, which is for the present worth, okay, a present worth or present value. And they have A, which is the annuity or the annual or annual uniform annual cost. And they have F, which is the future value of the money. And they came up with another letter is called G. G is for gradient. G is for gradient. Okay, uniform gradient amount. So gradient or uniform gradient. gradient, and F is the future worth of the money, future worth, and the A is the annuity or the uniform annual or uniform amount per period, uniform amount per period. A period, by the way, we're going to talk about a period, could be a day period or a month or a year. And B is the present worth, which is the value of the money at time zero, which is the present worth of the money, or the present value, present worth or present value. They put both, I believe, a present worth or a present value of the money. These four quantities, okay, they are related to each other through the interest rate I and the N. N is the number of the compounding periods. Compounding periods. And I is the interest rate. And in fact, we have two types of interest rate, the annual and the effective. This is why there is another letter we're going to see, I effective. If the money is compounded other than yearly, compounded monthly or daily, like the interest rate of our credit cards, they charge us the compounded daily. If I am 1 day late of paying my due, they charge me interest per day. Okay, so and we're going to see how can we get it from here to here. And okay, there is something is called cash flow diagram. Cash flow diagram is very important diagram, and I always encourage everybody, like in statics or mechanics of materials, we draw a sketch for whatever simple problem. You draw a sketch or a free body diagram or illustration is going to help you a lot to prepare for the exam. And you don't have to do this during the exam, but if you prepare enough and you draw a lot of sketches and a lot of illustrations, it will be very easy to visualize what's going on. What is a cash flow diagram? Basically, we draw a horizontal line and we start with the beginning of the period, whatever the period is. It could be a month or a year or a day or a week, and they will tell you. And we number them. We number 1, 2, 3, all the way until we hit the end. The first period, it has a beginning, it has an end. So I need you to be aware of, because the wording is very important. When we're saying that the beginning of the first period, let's assume the period is year. In years, let's take years. So this is the beginning of the first year. And this is the end of the first year and the beginning of the second year, and so on. So we need to be aware of that. So we draw a horizontal line and we indicate the number of compounding periods. If they are too many, if 25, I don't have to write 25 all the way from there. So we cut it here and we say that N is equal to 25, for example, where this is 25. We don't have to draw the whole thing. And we draw vertical lines. This is a P, which is a present worth value. The present value is always at time zero, always at time zero, at the beginning of the job or the beginning of the first compounding period. And after that, at the end of this project or the number of, we have something, okay, we call it F. The F could be either a money for whatever money they assign it to the project, or it could be what is known as SN. And the SN is expected salvage value, which is the value of the asset at the end of the use or at the end of the life in any year. They call it SN. Annual, it could be like that, annuity A, could be A, annual uniform per compounding period. G is very unique one, the gradient. The G, it is equal 0 at the end of the first period. The G will start to be like this. So the G, if this is A here, G is equal 1G at the end of the second year. So the equations, this is 1G. And here, this is 2G. And the G here is equal 0. This is the equations they provided, and the table is based on that. It's called the gradient. This is called the cash flow diagram. If you are able to draw the cash flow diagram in a very short time, because you have only a few minutes, or you can visualize the cash flow diagram in your brain because you practice enough, you will be able to convert any of these money, either B or A or G or F, or this, the salvage value, to any form that he wants. There are two ways. We have equations and we have interest tables. Normally, we don't recommend use the equations. The equations are lengthy and it could be time consuming, and it could be also source for error. But sometimes we have to use the equations, sometimes, or the formulas. Equations or formulas, let me use the word formula. Formulas, okay, to match the name that they are using. Even equation is a formula, but they came up with these formulas for us in order to convert it from us. So the factor name is given to converts, and the symbol they are using. And I will show you a very quick and easy way to remember the symbols. It is the F over B or B over F, because if we reverse it, we are going to have a problem. So this is the F over B, and this is the B over F, which is, you see, the reverse. Okay, A over F and A over B, F over A, B over A, B over G, F over G, and finally A over G. Okay, for any whatever interest rate is and whatever in compounding period, and they give us to convert what? We are converting, okay, F to convert to F given P. So, for example, I will be glad to draw all these cash flow diagrams, and maybe I have it in my book. For example, to convert to F given P. So P is given, this is given, and I need F. So the F is unknown. So the F in this case is equal P times 1 plus I to power N. So this is given, and this is to find, put a question mark. This, for example, here, like, so right now, if I have the cash flow diagram, let me draw it a little bigger. So at time 0, I have P. This is given. And I need, what is the future of this money? A certain number of years in, and the interest rate given, certain number of compounding periods. Sorry, I sometimes I use the years, but not necessarily the compounding period to be okay, to be a year. So this is the cash flow that for the first one. So they are saying that the F is equal P times 1 plus I to power N, which is this equation here. The 1 plus I to power N, this factor here can be obtained from the interest tables, where I go to the F over P. F over B. How I know I need to get the F over B factor? Because I'm looking for F. This is unknown. This factor here, it is the F over P. And we write it this way as N equal whatever is, and the I is equal what? Or you put I on the top or N at the bottom, it's not a big deal. This P and this B, they may be canceled. Well, don't cancel it, but as if you are canceling this with this, what is left is F. And this is what I'm looking for. This is how I know this factor is F over B, not P over F. Because look for what you are looking for. I put a question mark for this is the unknown. Unknown. And this is given. and so on with the respect of the other factors. We can draw a cash flow diagram for each one of these equations, okay? And we need to understand how to make the process of converting one to another, and nobody will ask you to memorize any of these equations. Normally, we don't use the formulas. We use the interest tables, which they are given here. Series of interest tables given, okay? They start with the I, with the interest of 0.5, and they give us these columns. Unfortunately, it does not have rows. In my book, normally when books were allowed to take, and probably you'll see some that I create rows and columns much easier to read. Here we have a problem. If you go, for example, for n, whatever n is equal 4, and you need to get a factor, you have to make sure that you are not going up or down. They make a bold face here for 5 and 10 and 15 and 20 and 25, and after that you jump to 100 here, so 25, okay, and so on. So we need to know which factor we're going to use from the column number 1 or column number 2 or column number 3, column number 4, 5, 6, 7, and 8. So there are 8 columns. Each one of them is representing a certain factor for whatever interest rate is. Normally we use the interest table, but make sure that this is going to be available to you as a PDF. Okay, and I believe I included the PDF of this book here in the USB. I needed to make sure, okay, I downloaded it from the NCAAS website. So I need you to be aware of the straight line command, horizontal line, to make sure that you draw a line at the proper compounding period so you don't go up or down. And this is a common mistake. Okay, so I hope. So they have 0.5 and the 1.0 and 1.5, 2.0, series of tables. In fact, there are some books they have complete, okay, list of interest rates, okay, 4, but here they give you, okay, a range 6, and right now 8 and 10, and this one here is 12, and this is 18. So if I have interest rate, for example, this is 12, and the second table is 18. If I have an interest rate of 14 or 15 or 16, whatever it is, in this case, there are 2 ways. If you have time, I would use the equations or formulas. If you don't have time, you can take the interpolation between these 2 values, between 12 and 18, and I will show you how to do that. And this section is immediately before, by the way, the civil engineering section. So I need you to master the PDF that you have, or is available on the NCAAS also. It's for free. They don't sell the book anymore. To the best of my knowledge, they don't sell the hard copies as far as the reference handbook, and they make it available, okay, as a PDF. So please try to get a copy, or if you look to my the green USB I sent to you, maybe already I included. For sure, I included the section that I get extracted. For sure, this is included in the section I send it to you. So the interest, okay, tables are available, and they provide us with, okay, the nomenclatures I was talking about. Let me go to the NCAAS. I am NCAAS page 230. So I'm still in the NCAAS. Normally I go with the original document, and after that I will go to my book. You will find that nomenclature and definitions, all these things are given. Okay, where A is a uniform amount per interest period. B as in boy is called benefit. We have something called benefit cost ratio. Book value, which is a BV. Book value is the value of the asset at any point of time of the life of the asset. It's called the book value, which is the first cost minus the sum of the depreciation. C is the cost. So when we are saying benefit cost ratio, we call it B over C. So this B as in boy and C. Okay. D is the inflation adjusted interest rate per period, and we're going to see that. D sub J is the depreciation per year J. EV expected value. F is the future worth value or amount. And lowercase f is the general inflation rate per interest period. And G, uppercase G, the uniform gradient amount per interest period. I is the interest rate per interest period. I effective, here it is. This is the effective, and there is equation. We're going to see it on the following page. I sub E is the annual effective interest. This is annual. If the okay, effective interest rate. Okay, if the interest rate is compounded daily or monthly or weekly. MARR, which is the minimum acceptable or attractive rate of return, the MARR. And there is a problem, I believe, I encourage to explain what is the minimum acceptable attractive. Either acceptable or attractive, both of them are acceptable, and this is why they provided here for you. Minimum acceptable rate of return or attractive, okay. M is the number of compounding periods per year. N is the number of compounding periods, okay? And B is the present worth or present value or amount. R is the nominal annual interest rate. We're going to see that. R. So we have the I effective and I and R. And they are going to be, okay, shown shortly. And finally, the S sub N, which is the salvage value. Salvage value or expected salvage value of year end. What is a salvage value? You buy a car, or a contractor is buying a construction equipment, and the contractor is using this equipment for certain number of years, and after certain number of years he decided to get rid of this equipment, so he will sell it. So the value of the asset at the end of the life, or when you decided to sell it or dispose it, like my car, I use my car, and after a certain number of years, okay, I decided to get rid of this car. The value of the car at the time of the sale is called the salvage value of the car. And the salvage value, the S sub N, the salvage value will be affected by the time of use, time, okay, time, okay. How many years did I use the equipment? Okay, the time and the usage. Okay, because time by itself is a factor. If I purchase a car in January 1st, 2024, brand new car, and I put it in my garage, I never really used it, and I decided to sell it in March the 3rd today, the value of the car will go down. I didn't use it, man, but it has been sitting in the garage the time. Okay, the time. Okay, but if I purchase the car in January 1st and I'm using the car every day for a business or for whatever job I have, and they decided to sell it today, its value will go down because of that, because of the time and the usage, the mileage in this case. So and we're going to see the salvage value. There are about more than one method, 5 or 6 methods of calculating the salvage value, like straight line depreciation. This is the easy one, and the accelerated cost recovery system, and sinking and double declining, the different methods, and we are going to see what. Okay, so this is okay. They have here subscripts. Subscript J is at the time J, N at the time N, and they have another equation here, F over G. Normally they write this here down, by the way, F over G, they moved it here. F over G is equal what? What is F over G? If you look to the, do you remember the columns I was telling you about? Okay, which I numbered them. for whatever interest rate is. This is, I use 0.5, which is the first table. Let us look for, I have A over G, which is the last column here, A over G. And I have a P over G. Do we have here F over G? Let's look here. F over G. No. So there is no column for the F over G. They said that we can get the F over G in 2 steps, which is the equation they provided. Let me show it to you. So they are saying that the F over G, here it is the F over A times the A over G. 2-step operation. They decided to do that. Okay. This is, and here it is. I need to get F over G. So again, imagine that you are cancel out the common letters. Here I have F over A and A over G, as if you are canceling this with it. We don't do that. We don't cancel. But what is the product? If I cancel this and this, you'll get F over G, and this is what we are looking for. So that means in order to get the F over G factor, I have to get the F over A factor from the table because it's available, and the A over G. So it is a 2-step operation and is not available. I need you to be aware of that. This is something, okay, I need you to be aware of that. If you flip the page, you will find the equation as far as non-annual compounding. The I effective is equal 1 plus R over M to power M minus 1. This is called effective interest rate. M is the number of compounding periods, okay, and R is the nominal interest rate per year. So for example, and I have a lot of problems you are going to see, if they told me that the interest rate I, okay, or R, let's take R, this is the rate of the interest rate is 12% per year. Okay, this is per year means that compounded yearly, compounded yearly. But if they said that I have R is equal to 12%, okay, per year, but it is compounded monthly. So every month they add the interest rate. This is what is meant. Here, compound yearly, they don't add the interest rate until the end of the year. Here they add the interest rate every month, and they added. So they came up with this equation to get the effective interest rate. It will be higher than 12, by the way. If you look to this equation, 1 plus R, okay, and we're going to see some problems. R is 12, and the M, the 12, and raised to 12, you'll find, okay, minus 1. You will find that the interest rate will be greater than. This is why the credit card statement sometimes becomes unbelievable. So for the and he has to tell you in the problem statement if the interest rate is compounded annually or non-annually. So the interest rate compounded annually. This is one. So I don't need to do anything. I will take the interest. I will interest tables and or non-annual compounding. Non-annual compounding. Okay, so this is something that I need you to be aware of. Other topic is a break-even analysis. We're going to see that where we have production and we have cost, break-even. Inflation is another topic, and they came up with this simple equation. We're going to see it. Depreciation, they have 2 methods here. Depreciation, they have the straight line depreciation, which is D sub J, which is a depreciation at year J is equal C. C is the first cost. First cost minus S sub N, which is the salvage value, divided by N with the number of years. Okay, this is the first method. they adopted in this book, which is easy and straightforward, and the interest rate will be uniform because it's constant value of depreciation every year. The second method, they call it modified accelerated cost recovery system, MACRS. This is the one the IRS using, as far as I know, the modified accelerated cost recovery system, where the depreciation for year J is equal a factor. What is a factor? A factor is coming in this table here. So this factor is called the factor. Here it is. It's called the MACRS factors. These are the factors. And in order to get the factor, I need two things. I need the recovery period. The recovery period, it must be given either 3 or 5 or 7 or 10. This must be given to you in the problem statement. And what year he is interested in. This also must be given. And basically, I go with the recovery period. With the these are percentage, by the way. All these are, for example, this 10%. So you take whatever factor from here and you multiply it by the first cost, which is C. So the factor, you can type from the table on the following, there doesn't have a number. Table page 232, the table from table page 232. Multiplied by the C. C is the first cost. C, as you remember from the previous page, is the first cost. Right, I needed to write this first cost, something like that. This is what I'm expecting you to write. Always right, always right. This is the only way to absorb the material. I need you to absorb it. It's not just sitting and listening and, okay, no, I don't believe in this. There is something called the book value. What's the book value? Book value, they are using BV, is the initial cost minus the sum of the D sub J. So I add, and we are going to solve problems. Taxation is another topic. Capitalized cost. Capitalized cost, we use it when the N is equal infinity. N is equal infinity. And they call this perpetual period. Here it is. What's perpetual period? A term that is used forever. When you put some money and the money will be invested to generate income forever. This is big schools, and I'm sure that you heard this before. Big schools, they have what is known as endowment. Endowment. I believe endowment with M here. It is M. Sorry, forgive me. There's a problem. Endowment, endowment, which is a money that donated by rich people. For example, Berkeley or Stanford or Princeton or Yale University. I was watching a program, by the way. There is about 25 schools. They have billions of dollars, billions, not million, billions of dollars donated. So they take this money, the donor will give the money, and they have a committee, and they invest the money, and the profit from the investment, they use it for scholarships and buildings and equipment and research, and so it's called so this money will stay over there forever. The donor, he's told that I will give you the $10 million as a donation from me, okay, for this school, for this cause, and this is forever, like the commercial diamond forever. When you buy diamond forever, and payment forever. Okay, the relationship between the P and the A is given by this, and I will show to you why ended with the P B is equal A over I. I is the interest rate. I will take the equation. It's called capitalized cost. This is a very unique name. I need to remember capitalized costs. Capitalized costs are a present worth value using an assumed perpetual period of time. So the value, okay, the present worth, its value when the n is equal infinity or perpetual service. This is bonds. We are going to talk about bonds because the state and federal, they sell bonds to generate money in order to build whatever project. A rate of return, which is the minimum acceptable or attractive rate of return. We're going to talk about that. And if you flip the page, this is the last page. This is benefit cost ratio, very important topic, B over C. And the benefit cost ratio must be exceeding or equal 1. For any private business, obviously it must exceeding 1. But for state and federal and local authority, the benefit cost ratio 1, they can live with 1 because they are not in the market to make money. But the benefit compared to cost normally is a good sign for if the project is good or bad. And this is a table. So this is a benefit cost ratio equation, the benefit over cost, and we're going to solve some problems, which is in a benefit cost analysis, the benefit, okay, of a project should exceed the estimated cost. Otherwise, we are losing money. The benefits must be exceeding the cost. And this is the table for the modified accelerated cost recovery. This is a factor they are going to get because the depreciation, D sub J, is equal to the first cost times what? Times a factor. The factor that obtained from here. And the factor, this is a percent. Okay. And after that, they added this recently, by the way. This was not economic decision trees. We're going to go over that. I will show you how to handle that. Okay. Decision node, chance node, outcome node. And they have here the expected value, the E sub V is given by this equation here. Okay. And we are going to see the decision tree or trees, how they are working. So after that, this is what's given in the NCEES. The interest tables comes after that, and this is a section that under the engineering economics. In my book, okay, in my book there is a chapter, okay, engineering economics. This is a chapter 3 of the in the order of the NCEES, and the number of questions you might see is 5 to 8 questions. 5 to 8 questions, engineering economics. So also you'll find exactly what I just talked about. So there's nothing really to go over. So I put them in sections like this. Okay. And after that, I start to explain things in very simple, okay, or a fashion, or a very simple way. Okay. And I start to do some calculations, some problems. And we need also, even the majority of the engineering economics problems will be calculations, but we still need to know or to understand the concept. So here, introduction, obviously the reading, I will leave it up to you. Value and interest, talk about the value of the money with time. And followed by a very simple problem. The amount that must be paid in 2 years to settle a current debt of 1,000 if the interest rate is given 6% is most nearly. So basically, again, I need to translate this to the cash flow diagram. Every problem here, if there is no cash flow diagram drawn, and some of them I left this intentionally, by the way, in order to encourage you to draw it. So at time 0, I borrowed $1,000. Now this is at time 0, and the bank or the person or the organization give me the 1,000. They told me within 2 years you have to return the money, Mr. Mansour, and the charge interest is equal 6%. So at the end of the second, this is the first year, this is the beginning of the first year, and this is the end of the first year and the beginning of the second year. After 2 years, I need to give the money back with the interest. I need to return the principal and the interest. So this is P and this is F. So F is equal P times F over P. For the interest rate, I is equal 6% and N is equal to. This is how we translate the cash flow diagram into equation. And right now the P is equal 1,000. And the F over B, as I told you, how I know that F over B, not B over F. As you can see here, I'm looking for F. This F, this is unknown. This is, you see, I put a check mark here. This is given. This is unknown. So if you imagine that you are canceling P with P, so what is left is F, which is the one I'm looking for. So we can use the interest tables. If you go to the 6% and the N is equal to, can you go to the 6%, please? And I'm sure that you use this 10,000 times or maybe. So if we have 6, that's good news. The 6 is here. 6 is here. And I need the factor. Which factor? F over B. What is F over B? F over B. Here it is. And I need it for 2. So it is 1.1236. 1.1236. 1.1236. Is this correct? Did I pick this right? Okay. So basically, if you multiply this is from the table, the interest tables. You multiply this, you will get $1,123.6, 1123. And normally they are using the word is most nearly. So 1123.6 is close to 1124. This is one way. The other way, which is like I said, draw cash flow diagram. Here it is. This is the cash flow diagram. So I leave a space. I need to practice, and I need to make sure. And this is very simple. We're going to see more complicated cases. Okay. In fact, the last time I taught the class, I have about 55 problems. I will send all the 55 problems to you guys with the solution. In addition to the problems here, I have a lot of problems here, but I need you to. But we start a little bit with the basics, and after that we move forward. There is another approach, and you say that why did you use the factor? This is a factor. This is the factor that we get it from the table, interest tables. We could use the formula. The formula, it says what? It says that P or F, I need F, sorry. F is equal B times 1 plus I to power N. So in this case, I would say P is equal 1,000, which is the present worth, which is the value of the asset at time 0, at the beginning, times 1 plus. What is the interest rate? 6%. How many years? 2. Can you do this for me very quick? And you have to master your calculator. We mentioned this. Okay. So 1 plus, so it is 1.06. 1.06 enter and square. And you multiply this by 1,000. I got 1123.6 again. And this is what you get. Okay, I needed to master that. So either use the equation, which I don't recommend. I recommend but if it is a simple problem like that, and instead of spending time to look for the interest table of the 6% and try to pick the value, and you are lucky if you didn't go up or down one line or one row, you didn't do mistake, maybe the equation will be very good approach, especially for the simple relationships. Like, for example, I have the P is given. Let me move my camera here because I'm drawing something here. B is given. Okay. And I'm looking for F for the I and the N. So we say that the F is equal P times 1 plus I to power N. By practice, you remember this relationship. But what about F? I have F is given, and I need to get the P. Also for the interest rate I and the N, whatever the N is, like here I and N, I put the N here, so we can put it here. So in this case, I am looking for P. So P is equal what? Is equal P, sorry, is equal to the F times 1 plus I 2 minus N. Or you divide, or you say F divided by 1 plus I to power N. And this is given, by the way, in the equations. I did not invent anything. It is just here it is. This is 1 plus I to power N, and the other 1 plus I to power minus N. This is F, okay, to be given F. These two relationships, they are very simple. To find F and B, or the relationship between F and B, these two relationships, probably if I were you on the exam, I will not bother to go to the interest tables, because simple equation and I can find it easily. Okay, I did it here like the kindergarten. Okay, that the value of the money after 1 year, this money will charge interest 6%. So I add, so the 1,000, which is a principal, plus the 1,000 times 6 will give me 10. And the second year, the principal is here, and the principal will be also charged 6%. I ended with 1124, which is the same. But I will never do this in the exam. But here is just to show you. Okay. Cash flow diagrams is very, very important. I explain it. And I talked about the B and the F and the G, the one we talked about it. Here are the formulas for interest factors. I do have another drawing. I don't know why I didn't include it. So this chapter has 23 problems. 23 problems. Okay. And as I told you, I have another set of problems. They are about 55. And I solve them. I believe it's hand solved, hand solution. And also they are typed, but I need to look for what they and also there is another table. Let me get it. Probably this will help you a lot Uh, yeah, this is one of my books, the construction depth for the construction right now for the PE is a very thick book, about 700 pages. Okay, this is, for example, another table that it has a cash flow diagram. Okay, probably I will send it to you, even I know it's not there, but I need you to be familiar with. And the interest table that I normally use for my classes, I do this. This is my tables. Obviously, it is the same tables that, but it has rows and columns, and but you are not allowed to take take this book with you anymore, or the PE also they are not allowed to take it anymore. So you have to use whatever I provided, and this is much easier. At least you will not really go up one line, uh, uh, up or down, or but the point is the cash flow diagrams. Okay, maybe it give you more probably I will scan it and send it to you in order to give you, and I will help you a lot with the cash flow diagrams, because we need to draw cash flow diagrams as much as we can. Okay, so this is very similar to the table we just talked about, and you can draw the cash flow diagram here if you want. And okay, so this is the F to find F given P. So this is 1 plus I to power n, and to find P given F, this is a 1/1 plus I to power n, or it is written as 1 plus I to minus n, like that. Okay, those are the two. I would say that the other formulas start to be getting a little bit okay. If you look to this problem, problem 3-2, 3-2. Okay, a new widget twister with a life of 6 years would save $2,000 in a production cost every year, 12 interest. The highest price that could be justified for this machine is, okay, right now I have a production, and this is n is equal 6, and this is n is equal 0, and every year, okay, I could save $2,000, save in a production. So $2,000, $2,000, all the way until the year 6. So I said that what is the highest price? Basically, this is A, which is annuity or annual. Again, I ask you, first sketch the cash flow diagram here. This is a cash flow diagram. What I'm looking for, I'm looking for the P. How much money I am willing to pay for this twister, widget crister, sorry. Because if I'm able to save $2,000 a year, how much I'm willing to pay for it? Because this money I could use it as an interest rate given to be 12%. So the P is unknown. So I said P is equal A, and I will cover this A, and I need P. This is unknown. So I should say that P over A for the I is equal 6, I is equal 12%, and N is equal 6, or it is A times A over P of I is equal 12% and 6, and N is equal 6. As I told you, this is unknown. So imagine if you cancel A with A, what is left is P. So this is the right one. But if you look to this, I cannot cancel B with A. So this is the A over B. No, it's supposed to be P over A. And this is what I did here, P over A. So try to test yourself by doing this. So the 2000 times P over A. So right now I need to get the factor. So the P over A, okay, for the interest rate is equal 12% and N is equal 6. Okay, I will go to the 12% and we are lucky that we have 12% table. So 12% and N is equal 6 and I am looking for P over A. So where is P over A? Here it is. P over A. You found it? Okay. So and the 6 is here. Okay. And the P over A, I got 4.1114. 4.114. Bingo. If you decided to use the equation, I will have to go to the table that has the equations and pick the right equation. If we go to the equations, here it is. I need to find B given A. B given A. What is B given A? Here it is. So this is the equation, which is, as I told you, is the P over A factor. I have to use this equation if the N that gave it to me does not exist in the table, or the interest rate does not exist. It will be time consuming. I don't expect that, but nobody knows. I need you to be ready for both, okay? To be ready for, okay, for, so always draw the cash flow diagram. Cash flow diagram. Okay? Types of interest rates, rate of return, and the minimum acceptable or attractive rate of return, minimum attractive rate of return. So the rate of return, ROR, the estimated interest rate produced by an investment. It may be computed by finding the interest rate such that the estimated income and non-cash benefits, okay, and the estimated expenditure and non-cash cost, negative values, okay, sum to a net equivalent value of 0. Rate of return, a definition that we are going to see it in one of the problems. Nobody will ask you to memorize it, but we need to understand what is meant by that. So rate of return, ROR. The second one, the one given in the book, it is, and the NCAAS, the minimum attractive or acceptable rate of return. If you remember in the NCAAS, this was given. So let us read it from the original document and see how this, okay. And also, okay, so the minimum acceptable rate of return, MARR, acceptable or attractive, is the interest rate that one is willing to accept, or the rate that one desires to earn on investment. The rate of return on investment is the interest rate that make the benefit and cost equal. So we have the minimum attractive rate of return, and this is the ROR, by the way, rate of return, ROR, rate of return. So the rate of return, ROR, we have the minimum attractive rate of return and the ROR. We need to know the difference between them. And the problem that you are going to see, okay, it will explain the difference between the rate of return for minimum attractive rate of return. This is what the contractor normally they set. They say that what is the minimum attractive or acceptable rate of return, because the contractors will borrow money from the banks and they have operating costs and they have the expenses, they have rent and they have insurance and they have. So what is the minimum acceptable rate of return. What is the minimum I can accept? But the rate of return on an investment is the interest rate that make the benefits and the costs are equal. Benefits equals costs. It's the rate of return. Like somebody purchase or planning to purchase certain number of units, he will ask, okay, what is the rate of return on my investment? I am going to buy 10 units for $1 million. How much is the yearly income after I deduct all the expenses and taxes and management and see how much is the rate of return on his money. Okay, so we are going to see that. So this is the ROR and the minimum attractive or acceptable rate of return. Okay, types of alternative sets: mutually exclusive alternatives and independent alternatives. A mutually exclusive alternatives, exactly one alternative must be selected. Example, shall Main Street be paved with concrete or asphalt? Okay, in which room, okay, shall we put, okay, the piano, for example? If a set of alternatives is mutually exclusive, it is important to determine whether the set includes the null, which is do nothing, okay, alternative. Serious consequences can arise from the failure to recognize the null alternative. And this is what we do, by the way, when we study, we prepare projects for a future job that will be implemented, who come up with series alternatives, and we add the do nothing, which is no build, they call it no build alternative, no build alternative. We are not going to do anything, or do nothing or no build alternative as one of the, if we keep the road as is, there is a road or there is a bridge or there is an intersection, has to be upgraded or improved or paved or fixed. So we'll discuss what are the alternatives. How many alternatives do we have? We have either asphalt or PCC. Should we use steel? Should we use concrete? And do we do it now? So we'll study all these things, and we are going to see some problems related to this hypothesis, and you will be okay. The second type of alternatives, independent alternatives, it is possible but not necessarily economical to select any number of available alternatives. Example, which street should be paved this year, okay, and so on. So if you look to the problem number 3-3, okay, a new excavator is needed for a construction company. The minimum attractive rate of return is 10%. This is this model and this model. The price, maintenance, salvage value, and the life. Here, the life of the assets are different. So select the better of the two available models based on the given information. I need you to be aware when the lives are different, one has 10 years and one, this is the N for the first one. This is for the XE model. And this is the N for XL model. Since the lives are different, the best way to compare is equivalent uniform annual cost, EUAC. Here it is. Equivalent uniform annual, which is annuity, A, simply A. I convert everything to be based on a yearly because they have two different lives. Sometimes we can use other methods like a present or future, but I have to make from this model XL another cycle. I will repeat another 5 years to make them the same life. But if this, as you can see here, let me because I need to use this for drawing the cash flow diagram. I'm sorry, I should not write here, or I will clean this area here. So I said that when the lives are different, okay, so this is the N, this is the N for the XE model, and this is the N for the XL model. So in this case, the best way to compare it, okay, select the better. How I select the better? The one it costs me less. So I can base this on the P or F or A. G normally is very difficult to use, or it is sometimes impossible. Because the G, as you know, it started at 0, okay, at the end of the first year, and I will show a problem. So either P or F or A. A, which they call it equivalent uniform annual cost, EUAC. Okay, now if you look to the cash flow diagram, which I cleaned this area here to show you the cash flow diagram, at least when we talked about different parameters. So the cash flow diagram, basically you are drawing a straight line. Okay, so I will go with the XE model, which is 10 years. Let me see if I can fit it here. Okay, so this is a time 0. It has a price at the beginning, 11,000. This is the value of the asset at time 0, which is P. And after that, the annual maintenance, so every year, 1 in here is equal 10. I'm not going to write all the way to the 10, but I will put the first year, for example, and the second year. Okay, and we do this. Here it is. This is A, which is equal $1,000 maintenance, and the maintenance goes all the way to the year 10. Uniform. At the end of the asset, there is a salvage value SN. How much? $1,000. Any question about that? This is called the cash flow diagram. This is a cash flow diagram for the XE model. I need to convert all this to make it annual, equivalent uniform annual cost. This is already annual, which is the 1,000, the annual maintenance. This every year. This is per year. I don't need to do anything. I will keep it, but I need to convert the 11,000, and I need to convert the 1,000, the SN. SN is a future with respect to this, by the way. So if you look to the XE model, I take the 11,000, which is P, multiplied by A over P. A over B, not B over A, because P will cancel with B. For N is equal 10, and interest rate is 10. I kept the 1,000 as is, because it's already A. And the F, it's minus. Why minus? Because in the opposite side. Because this is out of your bucket, this is out of your bucket, and this is in your bucket, in. We call it receipts and disbursements. So this is in your bucket, and this is out of your bucket. So minus, this is F. I need to bring it back. So F times A over F. I need to get it A, for N is equal 10, and this. Get the factors, and this is what I need you to check when you study. I need you to go and get the interest, the interest tables, 10%, and N is equal 10, and A over F. I need you to get these factors. I didn't do it here for you intentionally in order to show you. Okay, I need you to get it exactly as because I need you to practice. If you are going to see everything in front of you, so to study what? We need, I know I need to do it in your own. Even sometimes, as I told you before, cover it with a sheet, and after that you can judge yourself. And always when I solve problems, keep in mind the speed, because you have very limited time, and we need to make sure that we are really. So the first model, the XE, give me 2730. This is a cash flow for the, I need to draw the cash flow for the other model. Let me draw it here. The cash flow diagram for the XL. XL has only 5 years. So I will draw a straight line. And this is 0. What is the first cost? He's paying only 4,000 for it. So this is a $4,000 for P. And it is N is equal 5. And the first year I have 15. This is the year number 1, year number 2, and so on. I have $1,500. So A is equal $1,500 as an annual maintenance cost. And the salvage value here, there is no salvage value. He said 0. So the SN here is equal 0. So I need to convert this to this, which is the equivalent uniform annual cost for. So the 1,500 is already annual, so I kept it as is. All what I need to convert the 4,000. 4,000 A over B also, because this is P, and I got the factor, and it turned out to be 2560. So I have two numbers. Obviously, the cheaper one is going to be the governing one. This will govern this 2,700, and this is 2,570. So I have two numbers, this number and this number. Which one is the cheaper for me per year? Because this how much it cost me per year. And so that now we convert everything as the equivalent uniform annual cost, or simply a annuity. It's called annuity or yearly. The cheaper one, the smaller number. So this is 23, 27, 30, 25. So obviously the XL is the better. And this is why he selected the XL, which is the answer B. Sometimes, by the way, I rearrange these options and I don't fix this. Make sure that the answer here matches, okay, the number. Maybe the solution is correct, but sometimes any question about this? These are very easy problems. Very, very easy. Very, very easy. Okay. Let me see if there is any problem in the NCAAS, at least give you a taste of what the type of problems that you might see on the exam. I hope that I know what will be on the exam. I will be very lucky. And again, this is the chapter 3, which is engineering economics. As I told you, I am following the end. This is from 5 to 8 questions. We finished the statics from 8 to 12 questions. We finished mechanics of materials, which is 7, 11. Okay, so we need to make sure that we really these are 14 chapters. Some engineers, as I told you, they use even the book as is, and they passed. But you have to master. There are 14 chapters. Okay, 14 chapters. If you we need to master all the 14. Okay, but for whatever reason, if you master at least 10 chapters, 10, but I mean master mean that you need to get, okay, them master 10 out of 14. This what the students or my Fresno State students told me that they passed. Okay, so we will try to master 14 out of 14. I'm not saying that we are not going to satisfy with that, because I need it to be 150%, as I mentioned. So we need to be okay, because when you go to the exam, you will see some questions are very strange, and they use some kind of a question that they test. Uh, they use it for statistical reason, not necessarily to be counted, okay, toward your results. They put like for the PE, also they put some questions to test to see what could be used for the future exams. They use it for statistical analysis. So anyhow, the thing that out of our control, I don't really pay too much attention. I pay attention to what it's under our control, which is the study and the study and the study. Prepare and prepare and prepare. And you remember the triangle for the FE. You need to understand the concept and the practice, million time practice, and go to the exam with a strategy, as I mentioned before. Remember this triangle of success. Okay. So let us do our best. Okay. Uh, uh, okay. For example, okay, let's look to this problem here. Problem number 13. Number 13. Can you go ahead and start it? Let me give you 3 minutes. 3 minutes. Problem number 13, please. In front of you, if you don't have the book, here it is. The exam will be on the computer or the CBT. Okay. Obviously, on the exam, let me give you another minute or so. Let me just wait. Maybe one of you already got it. Okay, I think you got 3 minutes. This is the easiest problem that you can get. This, it shouldn't take more than 1 minute because it's similar to what we just did. Okay, and again, by the way, don't take anything personal when I say something. Like students also, I tell them in the class, when I say I don't really to saying something that to hurt somebody's feeling or insult anybody. No, I never. So never take anything personal. Sometimes I get upset, sometimes I get nervous, sometimes like in the classroom. This is the first day of the class. I always announce that, guys, I am here to serve you. I will serve you to the best of my knowledge and the best of my ability. So if you see that sometimes I get upset because I'm caring about you, or I say something, I don't mean to insult anybody or put anybody down. No, never. Never think this is not my character, this is not my behavior. And above all, it's against my religion, okay, which is I'm trying to practice my religion as much as I can. And also it is so never when I say, oh, this is the easiest problem that you can see, that means I'm not saying that. Okay, so do I need to draw the cash flow diagram? While I'm preparing for the exam, yes. But on the actual exam, I will never try to draw this. So you said that a company borrowed 100,000 now. So this is time zero. A company, Mr. Mansour's company, they went and borrowed this. Today at time zero. So this is P. Okay, and I is the 10%, sorry, 12% this per year. The monthly payment of a 5-year loan will be. So I have N is equal what? N is equal, I have 5 years times 12, so this means 60 months. And I start to pay back the first month. The compounding period is a so it is, this is A. I'm going to pay at the end of each month a certain amount to the company to return to the bank. Sorry, this is 60, this 59, and so on. So I'm looking for A. So the A is equal what? Is equal to the P times A over P, and the I, the interest rate, I will leave it, and N is equal 60. Here 60 months. He told you this is 12% per year. That means the I is 1%. And the N is equal 60. And I know maybe one of you will ask a question, I will answer it, but let us take one step at a time. This is a problem like this. I will never draw the cash flow diagram because I practice enough. But while you are studying, yes, I need you to draw the cash flow diagram. If I go to the interest tables and get this, can you get it for me, please? Anybody can tell me what is this? So I will put the 100,000 times whatever the number is. This number is, let's go to the interest tables. Either whatever book is, I will go to the 1%. Okay. Okay, and we are lucky that we have 1%. And N is equal 60. N is equal 60. And I need the A over B. Where is A over B? A over B, here it is, the column. Okay, so 60, I got 0.0222, 0.0222. How many twos? I think the 3 twos. Yes, a 3. I'm looking to the interest table. Here it is. So always okay. So in this case, if you multiply this, this will give you 1,000. So it will give you $2, okay, $20 per month. One of you may say, wait a second, is this going to be the same as You are giving me the factor, my friend. Let me look to see if you are giving me a factor or you have a question for me. Oh, thank you very much for your help. Yes, you are giving me the factor. Okay. Somebody may say, what about if I do the following? I said that the A is equal to the 100,000 I will get it per year, which is the A over P for I is equal 12 and N is equal 5. And after I get this number, this is per year, I will divide it by 12. This will give you what? So can you go to the A over B? I will go to 12% table right now. 12%, just I need you to answer. Okay, so 12% is here, and I need A over B for N is equal 5. So A over P for N is equal 5, okay, is 0.2774. This factor here is 0.2774. So if you multiply the 0.2774 times, okay, 0.2774, check my factor, please, and you multiply it by 100,000 times, and you divide it by 12, you will get what? You will get 2312. Is this correct? Did I pick the right factor? So if I go to interest table of 12.2774, N is equal 5, interest, and A over B 0.2774. And after I computed the payment for a year, I divided by 12. So this is going to give you a number which is 20. And I'm sure you are going to ask me a question. I did it one more time. So this will give you $2311.67. So two different answers. When he said that this is the nominal annual interest rate, nominal, even the numbers are, this is 2300, this is 2200, I'm still, even if I did a mistake and solve it that way by calculating the payment every year and divided by 12 months per year, and instead of multiplied 5 years times 12, even 2311, you're still willing to accept that the answer B is a correct answer. But the problem with this, if you do it that way, that the interest rate, if you look to this 2220 and you multiply this by 60 months, and you take 2311 and you multiply by 60 months, obviously this will give you higher. This will give you higher value, okay? Because this interest rate is given in nominal interest rate per year, annual interest rate. So this is that you are calculating the interest, okay, continuously like this every year, okay? Here for the N is equal 60, so I take month per month. So this is the correct way and the more accurate way, or the correct way, let me put it that way. Okay. So, but even, and we are lucky that he did not put 2311, by the way. We are lucky that he did not put 2311, because if you put 2311, we will be, let me 774 one more time. I'm gonna check something here. Okay. So I doubt they will do that. I doubt they will do that. Okay. So keep going. Keep all these ideas and issues. It will make more sense as we are going to proceed from one section to another, and we solve problems, especially if the interest rate is not compounded annually. Okay. Oh, 0.022. Okay, from the table, yes, for sure. Okay. If you go to the interest table of 1%, I will go to 1%. Here it is. One of you is asking me, okay, this is on page 233. Okay. And N is equal 60. Here it is, which is 5 years. So I went over this column and I need A over B. So I went down and I went horizontally for the N is equal 60. And this is what I'm telling you, try to use the straight line command. Here it is. And I got this number here, which is, let me zoom in. Where is the zoom in? Here it is. You got it? Good. Okay. So the following problem. Okay, the following problem is very interesting. And let me zoom out. Problem number 14. Can you look to number 14? This is, as I told you, this is easy and straightforward. Problem number 14. You must choose between 4 pieces of comparable equipment based on the cost and the salvage value given below. All 4 pieces has a life of 8 years. So N is equal 8 for all of them. The discount rate is 12%. Ignore taxes. The 2 most preferable equipment pieces and the approximate difference between the present worth value based on least cost are. So I have 4 types of equipment: A, B, C, D. He told you I need you to use the present worth, B. So I need to get the B for A and the B for B and the B for C and the B for D, because I don't know which one is the best. After that, I will select the least 2 pieces of equipment. They have the least present worth. And after that, he said that what is the difference? This is A and C, B and D, A and C, and B and D. As you can see here, A repeated here and repeated here twice. And the B repeated here and repeated here. And the same story with the D. So B and D, they go together, and A and C, they go together. So you need to compute the present worth for each piece of machinery based on first cost, annual cost, and salvage value, similar to what we just did. Okay. And after that, let me erase this. I should, at least I can draw the cash flow diagram for all of them here. The cash flow diagram for one of them is identical or similar to the others. So the cash flow diagram, if I take the cash flow diagram for A, what is happening? They are saying that I have 0 here, and the first cost is 25,000, and the N is equal 8, and the salvage value is 2,500, and the annual cost or the annual, okay, is 8,000, and the interest rate is for all of them is 12%. So all of them, they have the same, almost the same cash flow diagram, because they have, so this number will next time will be 35, the other one, and so on. So I can say that the present worth, or P, sometimes we say P, or is equal to the first one. It does have 25,000 as is, so there is no any change of the 25,000. I will keep it as is, a plus this here, which is 8,000. This is an A. I need to convert it to B. So 8,000 times B over A. For the I is 12, and this is 8, minus the 2,500. 2,500 times what? Times this is F. So it is a P over F for interest rate of 12. And so this is the present worth for the machinery A, which is 8,000, 25,000 as is, and I added the 8,000. It is repeated. All what I need you to do, okay, and the present worth of B is equal to what's B? 35,000. Okay, plus the annual cost, which is 6,000, times B over A for the same interest, minus the salvage value, which is 3,500. For this, the factors will be the same, by the way, B over F. So you need to get the factor only one time. Okay, and the present worth for C and the present worth for D. So you'll get the factor once, and after that do the calculations and decide what are the two, okay, that they are the two most preferable equipment. Preferable mean as far as the least present worth, since the N here is equal the same for all of them. N, as I said, that all of them. So here I can use either A or F or P, but I was forced to use the present worth. It said the difference between the present worth, so I have to use this. But when the N is the same for all the alternatives, it doesn't matter if you are using the A or F or P. Okay, so this is something that you can continue this problem, and please do it. If you look to the problem number 15, and we can conclude today's, okay, this problem here. A company can manufacture a product using hand tools. Tools will cost $1,000, and the manufacture cost per unit is $1.50. As alternative, so right now I have I can a tool 1,000, and the cost per unit is 150 per piece. This, okay, as alternative, an automated system will cost me 15,000. This is the automated system, and this is the hand tools. And this will reduce the price to make it 50 cents only. So this is per piece, per unit. So the unit here became 50 cents only per unit. With an anticipated annual volume of 5,000 units and neglecting the interest, what is the payback period in years for the investment? I am paying additional money here, but I am saving in the production cost. How many years does it take to get my money back? Oh, very simple. So the N, the number of years, or the back, is called back pay period, is equal what? I am paying $15,000 for this, for the auto system. And the hand tool, it cost me 1,000 only. So I am paying extra $14,000. But I'm saving money. How much I'm saving? I have 5,000 units. Okay. And originally the unit cost $1.50, but right now it costs only 50 cents. So right now I have 14,000 divided by 5,000 units times $1.50 minus 50 cents is $1, which is 5,000. So this will give me the number of years that I get my money back, which is called payback period. Okay, payback period as indicated. So it's 14,000, enter, 5,000 less than 3, obviously. It is 2.8. So 2.8 years. This is when I get my money back, and this is the answer, B as in boy. I hope this is the answer. Can you check the answers? Sometimes I do calculations and sometimes I don't. Okay. So he said that in neglecting interest rate. I have no problem with that. So these problems are really, really okay, and we're going to solve more. And I need you to be okay. Some problems it start to be a little bit more difficult, and we will do it. We will do it as long as we understand and we are drawing cash flow diagram correctly. I will continue this on a Friday. I will start with the benefit cost ratio. Benefit cost ratio is a very, very important topic, by the way. The benefit cost ratio. It is very, very important subject, benefit cost ratio. Okay, which is the as introduction, at least if you like to be ahead of the game. Okay, when we compare the benefits to the cost, I have 3 choices. Either I can use the equivalent annual cost or the annuity, the EUC of the benefits over EUC of the cost, or I can use the present, or I can use the future. We don't use G. It depends what the number of years N, similar to the problem we just talked about. If the N is the same for all alternatives, in this case, it doesn't matter, this or this or this. But if the N is different, normally we use the A, like this problem here. The problem immediately before that, the problem 3-3, if the number of years or the number of or the life of the asset is different. So in this case, we are using the equivalent, because equivalent uniform annual cost, because in this case we are converting everything based on annual, which is A, equivalent uniform annual cost. So this is number 1. Number 2, that I need you to be aware of the benefit cost ratio calculations, that the salvage value is not considered as a benefit. It is a reduction of the cost. So it is minus So remember, and I put it here because it's not given in the NCAAS book, unfortunately, that remember that the salvage value, SN, of an asset is a reduction of the cost, not as a benefit. Very, very important statement. And I needed to remember that. Is not, I know it is money coming into your pocket, but is a reduction. This is why we put it in the denominator, is not part of the benefits. I need you to be aware of that. And we are going to solve problems, and you are going to see how to do the benefit cost ratio analysis, because also this is another hot topic that it could be target for a question on the exam. Okay, so let us keep doing and depreciation, and I have a lot of problems here, and I will do all my best to keep you busy as long as you are healthy, you are wealthy, and as long as I'm healthy, I am wealthy. So on Friday, we are going to meet again from 5 to 7, and I will keep working with you guys, and hopefully that we can speed up a little bit, and keep adding hours and keep adding whatever I can add. I for sure I will never hesitate to help you all the way to the end. Okay, I will scan these sheets. I will send it to you, obviously, as usual, and the recording will be also available to you. I will do all my best to make it available as soon as I can. The moment that the company converted for me, I will load it on the net, and what so, and also any problem I solve here, probably I will scan it and send it to you, like this one here. Okay, and the mechanics of materials, did we solve any problem here today, or maybe maybe in the book? I will try to do my best to scan whatever I can scan and send it to you guys in order to make sure that. But please study hard, try to finish the problems, try to be ahead of the game, try to do your best. I know you are busy and you have a lot of work, and the moment that you send the statics problems, send it to me, because I will review them, and after that I will send you my solution, handwritten solution. At least you can compare it with yours, and after that, if you have any question, for sure I will be glad to answer it, even if I need to set a special session for that. I have no problem with that. Okay, so do your best, and I will do my best. If you are missing anything, let me know, and you are very, very welcome, my friend. Try to understand, try to absorb the material. I need you to absorb it. It's not just I'm not here to read. I'm not here to show you the PowerPoint presentation. Here it is, and I need you to know why we are doing this, and because the questions on the exam will be completely different from what you see on my books and any other book available in the market, because they always come up with the new questions. But if you understand the concept, it doesn't matter. It doesn't matter how they ask you, and I will do all my best to help you all the way to the end. Okay, I wish you the best. Bye bye, everybody.